Okay, Sleeping Warrior. Let's see if we can pick apart your stupidity.
Or explain it either. Let me know what drink you want. The first one's on me. It's at Riley's Bar for Real Scientists on Winner Street in Victory City, next to the derelict pub, The Globe. And he acknowledges it. Notice that he doesn't like it. He just acknowledges it. He says, "You want gas pressure? In a vacuum? Do you understand the definition of vacuum, Anthony?" Yeah, that's kind of the point. Is this an admission? Because it seems to me that he realises when it's presented in real world that you
can't. This is where your stupidity begins. And you know that's true. Because, I mean, look. You want us to believe that it's 14.7 psi, then boom! Vacuum of space. But what you don't seem to get through your thick fucking skull, sir, is that it's right at the surface, it's 14.7 psi. It immediately starts to drop as you move away from the surface toward this vacuum until you get to a specific point where, holy fucking shit, right next to this vacuum of space is almost zero pressure. And by almost, we're talking about a lot of zeros to the right of a decimal point. So, yes, you can have pressure next to a vacuum. You don't understand how air actually works. It's a physical molecule. And like anything physical, it has a gravity. And I know you hate that word. And I know you think that Einstein took away Newton's gravity. And I know you don't like the word force. But it doesn't matter how you describe it, because it is very much like a force. And even if it's something pushing down on something else, or something bending, it's still an action taking place, wherein things of physical quality, such as, I don't know, gas molecules, tend to respond to that force. In this case, they pack tightly against the surface of this planet until they can no longer get any closer to the center of it, and then whatever is left fills the space above it until there's no more gas, which creates what we would call a gradient. Now, if we talk about pressure gradient in a container, then you have to imagine a tire. I keep going over this over and over. I go over it over and over and over. Because somehow it seems confusing that what makes a tire rigid and stay inflated and create a cushion for you to drive upon, as opposed to a tire of rubber wrapped around a ring of metal flapping loosely as you drive, which you know is impossible to drive on at any speed, is pressure. The pressure pushes on every surface inside of the container and creates an even pressure throughout the entire thing. It's even because you're putting more volume of gas into a container than the container can actually hold. So what happens is it packs tightly together and then it pushes off one another, much like bricks on a fucking wall stacked upon one another to create an entire structure. So, in a container, the pressure is equal throughout. There is no gradient. You keep saying there is. You can't even demonstrate it. You just think there is. There isn't. However, on planet Earth, there is a gradient. And it starts off at 14.7-ish psi at the surface and begins to decrease gradually as it moves toward the vacuum of space.
Can't do it. But for some reason, he seems to evacuate his mind and create a vacuum when it comes to doing it in the heliocentric model.
No, he doesn't. It's impossible to show you pressure without a container in the confines of gravity, you dumb arse.
In your model, you've got a gas pressure in a vacuum, hillbilly blue balls. But this first line reads as though you understand it in real world, but for some reason, reality is suspended when it comes to your religion. I mean,
no, reality is suspended when it comes to your understanding of what we call a vacuum. A vacuum literally means There's no air. And while the third law, or second law, whatever is motion or physics of entropy, second law, it refers to heat mostly. But if we try to talk about molecules moving into a vacuum from higher pressure to lower pressure, it's more of an equalization factor. That is true, but there's actually a force pulling on it that's stronger than the force that the force of vacuum has, which is zero. So creating that on Earth is impossible because we are in the midst of that pull, and there's no way to escape it at the distance of on the surface of the planet. Oh, you guys are so adamant about using this gas pressure thing. And by the way, it is the only argument you have left. It is the one thing that you have left. At the very best, guys, flat earthers, you've got one argument that says maybe we don't know how the vacuum really is, or what gas pressure really means. That's it. But you're wrong about that. We do. We know how it works. You definitely don't have an argument that destroys anything about physics. And it's really sad that you hold on to this one so tightly. Then again, you guys do spend a lot of time denying and rejecting evidence in favor of anything that might actually make you right instead of actually doing science. I'm sorry, but this is ridiculous. And you pick on blue marble science like this, and I know it goes back and forth, but you are getting it wrong, and you're doing it on purpose. Listen.
Your model. He says, you want gas pressure in a vacuum? Do you understand the definition of vacuum, Anthony?
Right. There is no gas in a vacuum, so there will be no pressure. Unless there is a reason for that, in which case you'll get a bunch of molecules trying to pack itself in together on the surface of the planet. You know, it's a lot like human beings, right? We're stuck to the planet. And why? Same reason air is. It's the same fucking thing.
Yeah, that's called space. And the gas pressure bit would be Earth, hillbilly blue balls. My next video will clear up all of this for you guys. Well, unless it's going to be gas pressure in a vacuum without a pipe. Without, I don't have notifiers enabled, but...
Without a pipe. So, if we think about a pipe for gas pressure, what do you imagine that looks like on a ball? Also, what happens to that pipe that's open on the one side when it's next to a vacuum? Ugh, you guys are dumb. You guys kind of remind me of that scene in The Sixth Sense where it's Haley Joel Osment and he's like, I see dumb people. They don't know they're dumb. I bet you I can find it right now. Haley Joel Osment. I think it's M-A-N-T. Sixth Sense, maybe. There you go. Sixth Sense. I'm eating some chips. Don't judge. Well, here's one. Just to describe flat earthers quite a bit. Not dead people. Oh, misleading. Okay. He says, here it is. I see dumb people. They're everywhere. They don't know they're dumb. They walk around like everybody else. They don't even know they're dumb. Anthony Riley, You don't even know you're dumb. Gas pressure doesn't require a container. Gas pressure requires molecules of oxygen or whatever gas it is be compressed. It's an energy. It can be created without a container. It can be created with a container. But all in all, you've got it wrong. You're trying to latch on to one argument, your fleeting, failing argument. You've been shown several times that gas pressure doesn't need a container. And the kind of container that you're talking about, and you have moved the goalpost on, has to do with having all sides enclosed, 4 to 6 sides enclosed. And, well, I guess it'd be 6 sides at least, wouldn't it? Unless it's a ball. But they're all enclosed. There is no hole, because you're talking about it being up next to a vacuum. And the only way that anything could escape into a vacuum would be to have a breach in that particular container wall, right? So like a pipe, if it's open on one side, that would be a breach, and therefore your precious vacuum would suck it all out. You don't know anything about pressure. You haven't demonstrated that you know anything about it. All you do is talk. You talk without evidence, and you talk. At some point, you have to knock it off and start being honest with yourself. What point is that? Well, that's up to you, but it should be soon.